Mechanical Education Hub. I am Akash. Today we are going to study about impact of jets. So here we will use impulse momentum equation to calculate force. Force is nothing but rate of change in linear momentum. When we apply force on a body, then its momentum will change, and this change in momentum will be represented by the subtraction of initial momentum of body from its final momentum. This is the basic idea that we will apply in calculating impact of jets. Impact of jets. Now let us consider a nozzle from which a water jet is coming with flow mass velocity of m dot in kilogram per second. Here we are considering this m to be flow rate of mass. So m represented the amount of water coming per second. Now from here this water jet strikes a plate. From this red color I have shown plate. When this water jet strikes this plate, it spills into two equal halves. Let us consider this point 1 to be the entry point of water jet on the plate, and we consider point 2 to be the exit point of water jet from plate. Now this is force applied by water jet, and this will be the reaction force on the plate. Water jet is coming with velocity v1 and exiting the plate with velocity v2. Now half of the mass flow rate is exiting from this side of the plate, and half of the mass flow rate is exiting from this side of the plate. Now what will happen is, when water jet apply force on the plate, the momentum of plate will change, and that rate of change in linear momentum will be the reaction force will equal to the reaction force on plate. Linear momentum, reaction force over the plate will be equal to the rate of change in linear momentum, and rate of change in linear momentum will be equal to the final momentum minus initial momentum. Now momentum is basically mass into velocity. Here we have mass flow rate, so we will take mass flow rate into velocity. Here our final momentum will be m dot v2 minus initial momentum will be m dot v1. This will be force on the plate, and we know force of water jet and force of plate are equal and opposite action and reaction forces. So from here we can conclude that force of jet will be equal to negative of force on plate. So from here we can also write that force due to water jet will be negative of m dot v2 m dot v1, which further will be equal to m dot v1 minus m dot v2. So force of jet is m dot v1 minus m dot v2. This is the basic principle we will use behind the calculation of impact of water jets. Now moving on further, let us consider a simple scenario when water jet strikes a fixed flat plate in normal direction to plate or perpendicular to plate. Let us consider a nozzle from which water jet is coming and striking a fixed flat plate. And spills into two equal halves. Let us consider one to be the entry point, this point 1 to be the entry point of water jet on the plate, and 2 will be the exit point of water jet from the plate. This is our nozzle. Now this water jet will have some diameter also. I'm simply showing this with a straight line, but in actual case this will have some diameter also. Say diameter be d. It is entering with velocity v1 and exiting with velocity v2. Now similarly, m dot be the mass flow rate in kilogram per second. From here we will get reaction force of plate, and from here this will be our force applied by water jet. So I'm simply denoted this with Fj, and Fp will be the force of plate. Now if we want to calculate the cross-sectional area of this water jet, we will have one formula, that will be area of water, cross-sectional area of water jet will be pi by 4 d square. From here we can also calculate discharge. Discharge will be denoted with the capital letter Q. Discharge is area into velocity. When water jet is coming out from the nozzle, its velocity is V1. So I have used this V1. From here we will find out mass flow rate, or rho. Rho will be the density of water, A V1. Whenever we have mass, we simply use density will be mass per unit volume. But when we have mass flow rate, we use the term discharge here. For more simplification, see the units. If we have mass flow rate of kilogram per second, density is our mass per unit volume. Mass, unit of mass will be kilogram per unit volume. We have meter cube there. Area we have square meter, and velocity we have meter per second. This will go cancel. See, we have kilogram per second and kilogram per second. I use these units just to understand this simple equation. So mass flow rate is density into discharge. Now one more assumption we are taking here will be that the surface of this stationary plate will be equal. From this assumption we will conclude that velocity at entry point will be equal to velocity at exit point. Now we need to find force here in x direction, that is perpendicular to this plate, and force here in y direction, that is tangential to this plate. We already find this force Fj. So this force in tangential direction I can also write, so this force in normal direction I can also write this F in x direction will be Fn. Now this force will be m dot v1. We have m dot v1 minus m dot v2 minus. Now this is the momentum at exit point. Now we have this two exit point. We are considering that water splits into equal halves, that is mass flow rate will be divided into two equal halves, m dot by 2, m dot by 2. So m dot by 2, if you consider here, then m dot by 2 into v2. But in x direction or in normal direction to plate, we have exit velocity 0. So m dot by 2 into 0 plus m dot by 2 into 0, because here also water is exiting in tangential direction, not in normal direction. So in normal direction our velocity is 0 at exit point. So m dot by 2 into 0. This term will get cancelled, and our fx in force in x direction or force in normal direction will be m dot v1, and from here I can write that m dot will be rho a into v1, will get square of v1. The unit of this term will be in Newton. Now we need to find force in y direction or tangential force. I'll denote it with D. The formula we have is m dot v1 negative of m dot v2. So at entry we have mass flow rate of m dot, but water is entering in normal direction. So here we have v1 is the normal velocity or velocity in normal direction. So then at entry point, tangential velocity of water will be 0, negative of mass flow rate m dot by 2. I am considering here from here m dot by 2 into v2, m dot by 2 into v2. Now we know that velocity is vector quantity. So if I am taking this velocity to be positive, then automatically this velocity to be negative, because velocity is vector quantity. So we need to take direction also. So final momentum will be m dot by 2 into v2 plus m dot by 2 into negative of v2. If this will be positive, then this will be negative. We can also use this sign convention in reverse direction also. If I will consider this to be positive, then automatically this velocity from this side will be negative. So this negative term will come, and this negative will cancel this whole equation, and we will get Ft, tangential force or force in y direction, will be 0. Now from here we can conclude that whenever a jet strikes a plate, it will apply force only in normal direction, not in tangential direction.